Hi, so I'm Jennifer. Today I will be doing my mid-unit assignment for Unit 3. So first of all, for the first question, describe what happens to the domain and range for a logarithmic function under a vertical reflection. Support your explanation with diagrams. So here looking at this diagram, as you can see, I have the red line is the original function and the green line is the reflected function, which is multiplying a -1 in front of the log. And looking at the domain didn't change. They're all equals to our real number, but x has to be bigger than 0. As you can see here, looking at the original function, x is bigger than 0. And looking at the reflected one is also x equals to our real number, but bigger than 0. Okay, looking at the range, they are technically the same. They are all equals to our real number. But if you look at the end behavior, the original function, it is going to a positive infinity, and the reflected one is going to the negative infinity. And if you look at the 2 points over here, when x is equals to 3, for the original function, it is at around 0.5. When you look at the reflected function, it is at negative 0.5. So looking at number 2, describe what happens to the domain and range of a logarithmic function under both horizontal and a vertical translation. Support your explanation with diagrams. So for number 2, as you can see, we also have the original function over here, and for the new function, we have added a horizontal shift by shift right by 1 unit and a vertical shift up by 3 unit. And the equation now is log x minus 1 plus 3. So as you can see, looking at the graph, the domain of the original function is still x equals to our real number, but x must be bigger than 0. The range is y equals to our real number. But looking at our new function over here, our domain equals x is equals to our real number, but x must be bigger than 1. Because there is a horizontal shift right, which shifted the horizontal asymptote. It was in the original function, it was 0, and then it got shifted 1 unit right. That shift would be the new horizontal asymptote would be at 1. So that makes our domain is x equal our real number, but x must be bigger than 1. And now is our range. So even though that there is a vertical shift up by 3 units, it doesn't affect the range. The range is still y equals our real number. And even if a horizontal shift and a vertical shift is made, it still doesn't change its shape. It still is staying the same shape as the original function. So now looking at the last question, graph the function. A, graph the line y equals x on the same grid. Here's y equal x. And graph the inverse function of f inverse of x by reflecting f of x in the line of y equals x. So let's find the inverse of the function. y equals, and swap x and y. Times both by 2 to get rid of the function. Oopsie. And then rewrite it in the exponential. Then we get y equals 10 to the power of 2x plus 4. So the inverse of the function is 10 to the power of 2x plus 4. And here is the graph. And now C, determine the domain, range, and the equation of the asymptote of f inverse of x. So the domain x equals to all real number, because exponential functions are defined everywhere. Y equals all real number. So the range would be y equals to all real number, but y has to be bigger than 0. And the asymptote would be at y equals to 0. So for D would be over here, f inverse of x equals to 2x equals to 10 to the power of 2x plus 4. So that would be my Unit 3 midterm assignment. Thank you.